Welcome back, guys. So this is question 2.24 of our book Electric Circuits by Nilsson, and the statement of our question is for the circuit shown in figure P2.24. So this is the figure, and here we have to find a R. Okay, so this is R, we have to find it, and after finding it out, the part B of it is the power supplied by the 250 volt source. The only source here is this voltage source, and the power supplied by it we have to find it as well. Okay, so let us first write here the given data. So this is the 24 volts, and this current which is flowing through this 5 ohm resistor is known. When this is the source voltage, so we can see that it is connected here at these 2 points. So therefore the voltage here in these between these 2 points is 250 volts. So therefore if we consider this one at 0, so this one will be here will be 240 volts. Okay, similarly, in order to find out the voltage here, if this is the supplied voltage, this some voltage will be consumed here across this 5 ohm resistor, and we will get the voltage which is here. Okay, similarly, this is the current, this is 4 amps current, and we can see that this 5 ohm, this 10 ohm, these two are in series, so the same current has been flowing through both of them. Okay, so let me find out the voltage here. So let me call it this VA. In order to find the voltage here, the originally applied voltage is 240 volts. So the remaining voltage which will be here would be what? It would be 240, which is the supplied one, minus the voltage which is across this 5 ohm plus the voltage which is consumed by this 10 ohm. Okay, so these are the two voltages. Let me find them. So it will be 240 minus this will be I5 multiplied by 5, which is according to the Ohm's law, and similarly here this one will be I10 multiplied by the 10 ohm, which is this resistance. Okay, we can see here very clearly that I5 is equal to the I10, and this is, as these two are in series, so therefore this is 4 amps. So let me write these values. So it will be 240 minus, let me take it out, so this 4 is here, and this 5 plus 10 is 15. So here it will be, so it is now 240 minus this is 60. So the value of VA is what? That is 180 volts. Okay, so the value here is 180 volts. So now this voltage is known, this is already known, so we can clearly see that this is the current which is flowing through this branch. If the potential difference is known, we can very clearly and easily find out this current, and let me call this current as I of X. Okay, so this I of X is VA minus 0, which is this voltage, divided by the resistances which are 14 plus 6, so this is 20. Okay, so it will be 180 divided by 20, these two will cancel out, and it will be 9 amps. Okay, so this current is the 9 amps. The current which is coming towards this one is 4 amps, this one is 9 amps. So therefore this is also the current which is coming towards this node as well. Okay, so if we apply the KCL here, let me apply the KCL, and let me call this current as IY. So therefore according to KVL, IY plus 4 ampere is equal to the IX. Okay, or the value of IY is equal to IX, which is 9 minus 4, so this IY is, this is 5 amperes. Okay, this is the current which we know now. So at this point we know all these currents, these are known. So when we have found out this current, we can very easily calculate the potential drop here across this one. So here this is V of 4, so V4 is 4 multiplied by IY. Okay, so 4 multiplied by 5, so this is 20 volts. When this voltage is known, so this, which is the applied one here, can also be found out, and let me call it V of B. Okay, so let me call it VB. This is VB. So how to find it out? We can see that this VB minus VA will also be equal to the voltage which has been consumed here, and this is the original rule which we have applied here, because this is the applied one, this is the remaining one, so the consumed one will be here. So we can find it out. VB minus VA is equal to V4. Okay, let me write here all the values. So VB is equal to V4 plus VA. So V4 is how much? We have found it out, that is 20 volts. VA is how much? That is 180 volts. So this is now 200 volts. So this voltage is also known. What else do we have to find out? The potential difference across this R can be very easily found out by this one. Okay, so we have seen that this potential difference would be what? It would be 240 minus VB will be equal to VR. Let me write these values. So 240 minus VB, which is 200. Okay, so the value of VR would be here, and ultimately the value of VR would be 40 volts. Okay, so one thing is known here. The other thing which we have to find here is this I of R. Okay, so because once VR and IR would be found out, we will be easily finding out the value of R, that is VR divided by IR. We will be using this formula. These two are known, but the IR is still unknown. So therefore, if this is the current which is the applied one, or this is the same current which is going through here, if this is known, we can see that this is the 4 amps and the remaining one would be here. We can find it out as well. But here at this junction, we can see that this is the current, this one is also the current. So we have to find out these two currents. Let me call it I1. So here I1 plus IX, that is equal to IG, which is this current. But the value of I1 is still unknown. So therefore, the voltage VB is known. The potential difference across this 10 ohm is also known, and the resistance is also known. So therefore, the value of I1 is VB minus 0 divided by 10, which is 200 divided by 10. So that is 20 amps. Okay, taking it and putting it here, the value of IG would be equal to the value of I1 is 20. The value of IX is how much? That is 9. So we can clearly find out the value of IG, which is 29 amps. Okay, so this value is also known. So this is IG. 4 ampere is coming towards this 5 ohm, and the remaining one will be flowing through this R. So applying KCL, we will very easily find out the current through it, and that would be the 25 amperes. Okay, so the value of IR is 25. The value of VR is how much? That is 240 minus 200, that is 40 divided by 25. So finding it out, we will get what? The value of R would be 1.6 amperes. So this is the value of the resistance which we had to find out. So the part A is solved now. Now in order to find the solution of this part B, which is the power supplied by this 240 volt source. So therefore, in order to do so, let me use this color. So here the power supplied is equal to I multiplied by V. The I which is flowing through this one is IG. The value of it is already known, and that is 29. And the value of V is, which is the voltage source, 240. Multiplying them, we will get 6960 watts. And that is the solution of part B of our question. Okay, so that's it for today, in which we have seen the solution of question 2.24. If you have any question, you can ask me in the comment box. See you soon.